Departments A, B, and C have 10 employees each, and Department D has 20 employees. Departments A, B, C, and D have no employees in common. A task force is to be formed by selecting one employee from each of Departments A, B, and C, and 2 employees from Department D. How many different task forces are possible? So I really like this question because it is a combination question, but to get it, you can't simply blindly plug in to some formula and magically hope it spits out the right answer. You really have to understand how combinations work and when does order matter, when does order not matter, when do you have to get rid of duplicates, when do you not have to get rid of duplicates. And so I like this question because I think the reason people find combinations hard is because they simply just don't take the time to learn them conceptually or learn them logically. So what do we have here? So we got these 4 departments. In Department A, we have 10 employees. Department B, we have 10 employees. Department C's got 10 employees, and then Department D has 20 employees. And from these departments, we got to choose a task force with 5 people. And on this task force, we need 1 person from A, 1 person from B, 1 person from C, and then 2 people from D. So how many people do I have to choose from A? I got 10 people there. And then any of those 10 people can be paired with any of the 10 people that I can choose from B. Then any of the 100 people that I could choose from A or B can be paired with any of the 10 people that I could choose from C. That should give me my combos for just from departments A, B, and C. Now here's the thing. So we are choosing a team here, choosing a task force, which means order does not matter. And normally when order does not matter, it means we got to get rid of our duplicates. Because, for example, if I were to choose, if my 3 people I chose here, a person X, Y, and Z, well, I don't also want to count the team that is, Y, X, and Z, or Y, Z, and X, or Z, X, and Y, because these are all the same team. And so I would have to get rid of these. However, let's think about how this scenario here is framed, because this would be true if I just had I was choosing a team of 3 people and I had one pool of people, X, Y, Z, M, N, and O or something, because and then if I was just choosing 3 people, so I could choose any of these people in any of these spots. But here, I don't have a single pool of people. All these departments are separate. So if I choose person X from department A, well, I have no other way of choosing person X. I can't, if I fail to choose them here, it's not like I can choose them later on from department B, because there is no overlap between my departments. And so what that means is I do not have to get rid of any repeats. There won't be any repeats. Any 3-person team I can make from these 3 departments is going to be unique. So for this, I can just do 10 times 10 times 10, which is 1,000. Now I got to think about, well, what about my people from department D? So these people are all from the same pool. So if I choose person person G and person H are the 2 people that I choose from department D. Well, it is, I can choose G here and H here, or I can choose H here and G here. So because whichever 2 people I choose are coming from the same pool, here I do have to get rid of my duplicates, because I do not want to count both GH and HG. Those are the same 2 people. So this guy here is just going to be, I have 20 people and I got to choose 2 of them. So that is 20 choose 2. So that number is going to be 20 factorial over 20 minus 2 factorial, 18 factorial times 2 factorial. So I got 20 times 19. Then from 18 on down, that's going to cancel out my 18 factorial, leave me with just 2 times 1. And this is 10, so this is going to be 190. So my total number of teams, 5-person teams that I can make is going to be 10 times 10 times 10 times 190, or 1,000 times 190, which is 19 with 4 zeros, 190,000 possible teams or task forces.